Okay, so first section we're going to look at in the book is section 1.1. It's on two formulas using coordinates. Okay, both of these formulas involve coordinates. And the two formulas, the first one we're going to look at is the distance formula, and the second one we're going to look at is the midpoint formula. Okay, on most tests, okay, not all, but on most, you can use a reference sheet. So if you want to take these formulas down so you can put them on a reference sheet later, might be a good idea. Or you can always go back in the video and just check them out. All right, so basic idea of the distance formula. Okay, you've got 2 points. Okay, I'm going to call them points A and B. And each point has its own coordinates. I'm not using any numbers. In a little bit, we're going to do an example with actual numbers, and I'll give you the coordinates. For now, it's just kind of generic. Point A has an x and a y value. Point B has an x and a y value. They could be the same x's, different. It doesn't matter. Okay, but A and B each have their own coordinates. Let me make this a little smaller. And the idea is we have something, don't worry about this triangle yet, something like that. Okay. Point A is right at the bottom. Point B is up in quadrant 1. And my goal is to find the length of the segment that I just drew. Now, if point B was right on the x-axis, that would be a lot easier. If I had an axis and a point here and a point here, and they're lined up straight like that, all I'd have to do is count how many units. But when it's on an angle, I can't do that. So looking at that line segment that I just drew, and keeping in mind what I said about trigonometry, does anyone have an idea of what shape I can make? And the line segment AB is going to be one of the sides of that shape. Yeah, Shelby?
A triangle?
Yeah, we're going to make a triangle out of it. Specifically, I'm going to make a right triangle, which I have right there. Okay, so I just made a right triangle where the line segment AB is the longest side. And Tristan, do you remember what the longest side is called?
Hypotenuse.
Hypotenuse. Yep, very good. So the goal is to find the hypotenuse. Now, there's a theorem that you can use from geometry if you know two sides of a triangle to find the third. Does anyone remember the name of the theorem, Waleed?
Pythagorean Theorem.
The Pythagorean Theorem. The only thing you got to do, though, is you have to know how long is that side and how long is that side. I want to find the lengths of those two sides. Well, let's make it a little bigger. Let's put a green dot right there. Okay. It's not really part of the problem. It's not the distance between A and B, but it does have a coordinate. And let me fix that. Y2. What's the x value of that dot? I just made it black. But what's the x value of that dot? How far to the right is it? We don't have a number for it, but we do have a label for it. Yep?
It would be x2.
It's x2. How do we know it? Because B is directly above it. And any 2 points that line up vertically have exactly the same x value. Okay, so that's x2. Okay, now I want to use the same reasoning to get the y value. We don't want to put a number, but it has the same y value as something else in that picture. Does anybody see what the y value would be for that point in black? Want to take a guess, Elise?
Y1.
It's y1. How do we know that? This point is exactly the same height as that point. If 2 points are at the same height, they share y values. All right. So now we can find the length of the 2 black sides in the triangle. Let's start with the bottom one. That's at x1. That's at x2. So we can find the length between x1 and x2 by what operation would you use? If you have 2 numbers and you want to know how far apart they are, what do you do with the 2 numbers? Yeah, Mark?
You subtract the smaller one from the larger one?
Yeah, subtract them. So like if I said to you this morning the temperature was 70, now it's 92, what's the difference? Well, just by asking that question, I've told you what to do, find the difference. So all we have to do is subtract to find the length of the bottom, x2 minus x1. That's the length of the bottom side. You just have to fill in whatever x2 and x1 are. And I'll give you numbers to fill in a second. Now, using the same kind of idea, anyone think they could tell me what the height of the triangle would be? Yep, Tristan?
y2 minus y1.
Yeah. That's at a height of y2. That's at a height of y1. Take those 2 numbers and subtract them. So if the y2 was 12 and y1 was 4, they would be 8 units apart. Just subtract y2 minus y1. Okay. So now we just take the length of the bottom, the height, and we fill those 2 things I just circled into the Pythagorean theorem. Can someone remind me what the Pythagorean theorem is? Yeah.
A squared plus b squared equals c squared.
Okay, and now I don't have a C up on the board or anything, so can you tell me what does the C stand for?
The hypotenuse.
That's the hypotenuse. And what about the A and the B?
I don't remember the name. It's x and y. But I don't remember this.
Yeah, does anyone remember what the short sides are called in a triangle?
Legs.
The legs. Yep. So now just take that, plug it in for A, take that, and plug it in for B. And there's your distance formula. Okay, so we'll go back to the other page where I already have that written. All right, now you get rid of that. And let's kind of look at the formula. So I've got one side squared, x2 minus x1, that's the bottom, squared, plus another side squared, y2 minus y1 squared. So I've got the addition, I've got the square, but now I've got that square root. Now that's not what Matt told me. He didn't give me a square root. How come I've got a square root in the formula on the right? I don't have any square root in the one on the left. But they really are the same thing. Yeah?
They cancel each other out because, oh no, I'm thinking the wrong thing about that.
Yeah?
Because when you add a squared and b squared, you get c squared, and to find c itself, you have to get the square root.
Right. The whole goal with the Pythagorean theorem isn't to find the length of something squared. You want the length of something. So to get rid of that square, we take the square root of both sides, and that's exactly what the distance formula is. Okay? It's just the Pythagorean theorem. Right, so now we'll try that with some actual numbers. Okay, so I want to find the distance between the points 4, 5 and 3, 2. Now, nothing here is labeled x1, x2, y1, or y2. So, Tiffany, let's start with the 4. Right now, I have a choice of what I want to label that. out of the four things I just said, x1, x2, y1, y2, what could I label the floor as?
X1.
Yeah, it could be x1 or
X2.
which could you just say it one more time?
X2.
It could be x2. It can be either one, it doesn't matter. But once you pick, then everything else is automatic. So let's call it x1. Right, so Cameron, now that the first one is x1, what does the 5 have to be? Oh, sorry. Do you have two Camerons? All right, yeah, go ahead. What did you say?
Y1.
Y1. Yeah. Did you answer 2, Dan? Or someone? I thought it was someone else. So that's Y1. And now the 3. How about Tyler? What's the 3? Oh, sorry. We have 2 Tylers, don't we? Yeah, Tyler.
Maybe x2.
X2. Okay. And then that automatically makes that Y2. Okay. So now just fill everything into the formula. What I like to do, you don't have to do it this way, but I like to write down all the symbols so I don't forget to do anything. So if I do all that, I won't forget to square, subtract, or take the square root, or add. Okay, let's fill it in. Well, Audrey, can you tell me what would go in the first set of parentheses? Not sure? You want to help her out? Yeah, Tyler?
Is it 4 and 3?
Okay, we're going to use the 4 and the 3. And just to make sure we follow the pattern we have there, which one are you going to do first?
The bigger one, the 4.
So what's the first one that I underlined right in the parentheses?
X2.
And what's x2 here?
Oh, the 3.
The 3, yeah. So we're going to go 3 minus 4. Turns out it doesn't really matter, but just to make sure what I'm writing is consistent with the formula, I'll make it match up. All right. And how about, Thomas, can you tell me for the last part what I'm going to fill in?
2 and 5.
2 and 5, in that order?
Yes.
Yep, exactly. All right, so let's do that. So the first thing I have is 3 minus 4. And Dan, what's 3 minus 4?
Negative.
Yep. And when you square it, you get? 1. Yep. And the next one, Dominic, what's 2 minus 5? Yep. And then negative 3 squared gives you? Perfect. So we get square root of 10, and we're done. If they don't ask me for a decimal, I can leave the answer just like that. Okay. If they want a decimal, then you use your calculator and just type it in. Every calculator is a little different, but that's what you do on that one. Okay. Any question on that? All right, let's try this one. And something's going to happen on this one that didn't happen on the last one. And this is the point of why I'm showing you the distance formula, okay? Because of something that is going to happen with a square root. All right. I'm going to start it off the same way. I'm just going to set up everything I need to fill in. And how about Mark, can you tell me, and it's up to you, you have 2 options here, what would go in the first set of parentheses?
2 and 4.
Yep, and what order do you want to subtract them in?
4 minus 2.
Sure, that's fine. Now, when we set up the second set, let's just do it the same way he did the first set. So, Patrick, can you tell me how to do the second one?
10 minus 6.
Perfect. 10 minus 6. All right, So we get 4 minus 2 gives me 2 squared, which is 4. 10 minus 6 is 4, squared is 16. So I get the square root of 20. But the square root of 20, you can do something with that. Anybody know what I can do with the square root of 20? Yeah, Tom?
Can't you break it down and simplify it?
Yeah, you can simplify it. And I have the steps on the next page, but for now I'm just going to tell you. You want to break it up into 2 numbers, something times something, that gives you 20. And one of the numbers has to be something you can take the square root of nicely in your head. So there's a couple ways you can write 20, like you could do 40 times a half. That's not really going to help. But there is one way that would help.
4 and 5.
Yeah, 4 and 5. Some people make a factor tree. That's okay too if you want to do it that way. But I usually just break it up that way. And now the square root of 4 gives me 2. So the final answer is 2 square roots of 5. Okay, so what we just did was reducing a root. So anytime you come across a root on a test or in the homework, it will always expect you to reduce it as much as you can. Okay? And if you have another way to do it, that's fine with me.
Since we're doing distance, do you want us to include units after answer 2?
Not unless they give you units in the problem.
Okay.
If they just give you generic coordinates and you don't know if the grid is measuring miles, feet, you can just leave it like that. That's okay. But yet, most of the time, labels are important. Just not on this one. Okay. So here's what we did to simplify the square root of 20. If you get what we did, you don't have to write that down. If you don't know how to reduce a square root, I would write that down. So the first step is to factor the number under the root, the radicand. We factored it into 4 times 5. You've got to pick 2 numbers that one of them you can take the square root of easily in your head. So when you try to factor it, use numbers like 4, 9, 16, 25, anything like that. Those numbers are all perfect squares. And then the second thing, once you factor it, one of them you'll be able to take the square root of nicely in your head, so you simplify what you can. Okay, so let's try, we already did square root of 20, let's just try square root of 48. Anybody give me 2 numbers that multiply to give me 48? And one of them I want to take the square root of. And this one, there's several ways to do it and still get the right answer. Yeah, Dan? I'm sorry, Thomas. 4 and 12. 4 times 12 is 48. Square root of 4 is 2. Now, look at 12. Can we break up the square root of 12 at all? Right. If you find you have to do it again, like we already did it once, that means if you're doing it a second time, we didn't pick the biggest number to start with. We could have done 16 times 3 for 48, and that would have done the whole problem in one step. But breaking it up this way and doing it in 2 steps, it's perfectly fine. Okay. So 2. And how do we break up 12? Matt?
4 and 3.
4 and 3.
And you can split up 4 into 2.
Yep. The square root of 4, Matt just said, is 2. 2 times 2 is 4. Square root of 3. If you did the square root of 16 times the square root of 3, there's square root of 16 is 4. You get it in one step. But a lot of times I don't always try to do it in one step. Just if I have to do it a couple times until I finally get it small enough, that's how I do it. Okay. Any question before we look at last one? Okay, so last formula is the midpoint formula. A little easier than distance formula. There's no square root. but it's giving you a different kind of answer. The answer here is not a single number for how long something is. The answer is a location. So the midpoint formula is answering the question where. Where is something? So the answer is two numbers, an x coordinate, or an x value, and a y value. Now, if you look at what we're doing right here, and the same thing here, you're adding up two things and dividing by 2. There's a name for that. If you add up two numbers and then divide by 2, it gives you the blank of the two numbers. Anybody know what I'm thinking of? Yeah.
The average.
It's the average. So I don't even remember this formula. All I remember is, with the midpoint, take the average of the x's, comma, then take the average of the y's. That's all it is. Average the x's, average the y's, there's your midpoint. Okay, let's finish up by finding the midpoint between these 2 points. So we've got the point 3, 4 and 7, 13. Right, so Serenity, let's start with the x's. If we add them up, what do we get when we add up the x's? Yep, 10, and then divide it by 2 gives me 5. So the midpoint is 5, comma, 4 plus 13 gives me 17. If they don't ask for a decimal, you can leave it just like that. That's fine. If they did want a decimal, what's half of 17?
8.7, right? I think.
Close, 8.5. Yeah, 8.5. I think you were thinking of half of 17 and a half.
Yeah.
Yeah. So 5, comma, 8.5. And that's the midpoint formula. Be careful on the test. I've had some people mess up this whole section because here you're adding x1 and x2, but here you're subtracting x1 and x2. Don't mix that up. Okay, put it on a reference sheet. Okay. So that's it for section 1.1. So the homework, 15 to 21 odd is distance problems. 39 to 43 odd is midpoint. And then these square roots, we need to copy these 4 down. Those are not in the book. They'll be in the video in a little bit. Copy those down. Oh, and bring the syllabus sheet back signed.